What's up, folks? This is the 4th video on the dreaded subject of data structures. And now, we're about to continue and focus on the menu for today is gonna be stacks, queues, trees, and hash tables. Hash tables. Stand by. This video is about to start. This is the savage scientist Ed right here. And I'm over the So let's talk about the stack data structure. That's the first one on our menu for today. The stack. Alright, it is one of the basic computer science data structures here. And the stack has basic principles. These rules must be followed for it to be able to be called a stack. What push means is you adding something to the stack, and what pop means is we taking something from the stack. Alright, you can't access the middle of the stack. And the last thing is, it's a last in, first out, and LIFO data structure. So real world stack would probably be a stack of dishes, a stack of cards, or a stack of cars. And you can look at a stack as a lazy data structure. Imagine this stack of cars. To get to the bottom car, you have to take the top car off. So in most of the cases, you're going to be taking or doing all your action from the top of the stack. You're not going to want to get something off the bottom of a stack because it requires more work. And that's what makes a stack a stack. So I just want to give y'all a quick graphical representation of a stack. Remember, we had the push and pop functions and this LIFO, last in, first out. So as I put this here, we have the push and the pop operations happening at the top of this stack. And as you start removing things from the stack, you're going to eventually get down to the bottom of this stack. So once the stack is empty, you normally would have a function called isEmpty. So let me demonstrate this with some cards here. So what I'm going to do is push cards to the top of this stack. Push, push, push. And let me straighten this up. Push, push. So I just pushed 5 cards to the top of the stack. So now I'm about to start revealing them with the pop operation. Pop 1, that's the jack there. Let's see, pop 2, queen, pop 3, that's a 9, pop, pop. All the way down to the, what is that? That's the top of the stack with this 9 of diamonds. So that's it. So you know it's called push when you put the items back in the deck. So I'm push, 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 and push. I just pushed the 5 cards back to the desk, back to the deck. And if you notice, if I start popping these cards again, they're going to all be in the same order or preserved order. And that's what makes stacks important. So you use this a lot in assembly language programming or systems programming, where you have to save the state of the registers as you go and branch off and start using those registers for other things. And instead of having to link all this stuff together, you could easily just use push and pop functions to get things done. And that's a lot faster and it's a lot more efficient than having to map them to the register. So I think I done nailed these stacks into the ground. So it's time to move to the next data structure, which is the queue. And now it's time to talk about the queue data structure. The queue. The queue is a basic data structure that works more like a line at Walmart. And when you're in line in Walmart, picture people in line. We have 3 people in line right here. Chances. This person, and this is the person that's the checkout. So, you know, this is line number 6. So this person is the next to check out in line because they next. I mean, think a line. And a queue has special functions that we know as Enqueue and Dequeue. So let me show you what I mean by this. So here go our queue. That's our queue. And when you put something in the queue, it's called enqueue. Enqueue. That was my bad spelling too. And when you remove something, it's called dequeue. Dequue. Dequeue. I know they have a lot of bad. I have to correct my spelling, so Dequue. If it's spelled wrong, then don't worry about it. So when you add something, it's called enqueue. When you remove something, it's called dequeue. So that's the basic structure of a queue. Alright, so we all know what a queue is, but just for the simplicity of this video, I'm about to make a queue with these cards. The basic functionality of this queue is going to be cards in line. It's kind of like people in line. So we got the first card in line, and as I add this second card right here, this card is gonna make it so the lines start moving towards the other end. We have two cards in line, so let's enqueue again to the third card. So it's called enqueue, mean in line. So we're getting in line. So we have 4 cards in line. So this is the order they will be removed. First, second, third, fourth card in line. So now we are about to start dequeuing or removing the cards from the deck, or removing them from the queue. We got the first one out of the queue, and we're gonna put that over here on the side here because that card is processed. Right now, a new card could enqueue and it'll take the 4th position in line. So let me get this out the way. So let's dequeue again. And now we're about to reveal this 10 of diamonds. And now let's dequeue one more time. And that's the jack. And the final card is dequeued. And now the queue is empty. This illustrates the behavior of a queue to remove items in an order they were received. Kind of sound like waiting in line at the Department of Labor. Damn it. So now let's move on to another example, this time with the iterator. Now this example is going to look extremely close to the last example here, but this time I'm using the iterator. So we're going to do the enqueue just like we did last time. Let me write this out. Yeah, we're going to enqueue or get in line, and like people from New Orleans know how to get in line. So let's start enqueuing these cards now. So we just enqueued the first, second, third, and now the 4th and 5th card. We have 5 cards this time. So I just enqueued these 5 cards. So now I'm about to bring the iterator into the position of the first card that's going to be removed from the deck. So let's put some labels on here for the front and the back of this queue. And I'm about to start the dequeue process, and that is just to flip the card. That's what dequeue means. So now we're going to start with the iterator and put it in the front of the list. And then there it is. And put it in the front of the queue, not list. So we got the 9 of diamonds. So now I'm about to move the iterator down to the next card. And this one is let me flip it over. It's the jack. So we got the jack right here. And let's move the iterator to the 3rd card from the front. That's the king. And now we're about to move the iterator down to the 4th card from the front of this thing. And that's the queen. And now the last card, or the last card to enter the queue, is about to be flipped. And this is 10 of diamonds. So we just visited all the cards in this queue. And remember, a queue is a first in, first out. FIFO. First in, first out data structure. And the green arrow is the iterator. It pointed to each card from the start to the end of the list, or the front to the end of our queue, not list. So since I'm talking about lists, this queue was implemented using a list. And remember that a list is just a data structure that has links to the next item in the list. And this list visited, or each card was visited through the links until it got to the 5th card, which is the 10 of diamonds. And once it got there, that's the end of our list. So the iterator visited each card by looking at the link. Let me just give you a queue and a stack, so we could go over the differences now. This is a stack. This is a stack right here. And this is a queue. And I'm going to draw them exactly the same. When you put something into the stack, you're gonna put it in right here. When you put something in the queue, you're gonna do it right here the same way, right? But when you remove from a stack, you remove from here. And when you remove from a queue, you remove from the other end. And this might, so let's say that we have 5 things in this stack and 5 things in this queue. When we put something new right here, this one will have to wait its turn to get processed or to get here. So if we put something new on this stack, it's going to be the next one to get processed. That's it. So that's why it's called first in, first out, last in, first out. So this is the last thing in, and it is the first one to get processed. So that's basically it for stacks and queues. And now we just looked at the difference. Just remember, all the action happens up here. With a queue, you have actions on both ends. Now we're about to move into trees and hash tables. So stand by for the next video. Peace out. One more thing. If you have some questions, see some errors, let me know in the comments below. But don't be a about it, because I will go savage on you. And it will look better. Do it look better like that, then let me know too. So till I make my next video, peace out.